20 trillion gallons. Not a typo, not a thumbnail exaggeration. That is the documented volume of water California's own governor cited when he stood in front of reporters describing something worth paying close attention to, a seasonal outlook stating plainly that as the state moves out of its dry season this fall, atmospheric rivers are considered likely once the wet season gets underway. That is not a prediction of another 20 trillion gallon event. It's important to be precise about that distinction right from the start. But it is official confirmation that the exact mechanism responsible for one of the most destructive and most water abundant weather sequences in modern California history is squarely back on the list of things state forecasters are actively watching for in the months directly ahead. Stay with this, because understanding exactly how a river can exist floating invisibly above an ocean, and why a number this large is a documented calculation rather than a scare tactic, is the only way to actually understand what California's own planners are bracing for right now. Let's start with the number itself, because on its own it's simply too large for a human brain to process in any meaningful way. Picture a flat surface exactly the size of the entire state of California, all 163,000 square miles of it. Mountains, valleys, deserts, and coastline included. Now imagine covering that entire surface in more than half a foot of standing water all at once. That's roughly the volume being described. During a run of storms in early January of 2023, an atmospheric science student at UC Davis ran the actual math using rainfall totals published by the National Weather Prediction Center, applying a standard hydrology conversion where a single inch of rainfall falling across 1 acre equals approximately 27,154 gallons of water. Multiply that conversion across California's statewide average rainfall of roughly 8.5 inches over that specific stretch of weeks, applied across every acre in the state. And the resulting figure lands somewhere between 22 and 25 trillion gallons of water delivered to a single state in about 16 days. California's own governor cited an extremely similar figure at the time, and he wasn't speaking hypothetically. He was standing in front of a state that had just absorbed 9 separate atmospheric rivers in immediate succession, with federal disaster declarations already being issued across multiple counties as he spoke. Now, let's actually explain the mechanism itself, because the phrase atmospheric river sounds like poetic exaggeration, and it's genuinely the opposite. It's a precise, technical, measurable meteorological phenomenon, and once you understand how it actually works, a 20 trillion gallon total stops sounding impossible and starts making complete sense. An atmospheric river is a long, narrow corridor of concentrated water vapor flowing through the sky, typically stretching from tropical or subtropical waters out toward the coastline, carrying enormous quantities of moisture at relatively low altitude. According to NOAA, a single strong atmospheric river event can transport a volume of water vapor roughly equivalent to the average flow rate at the mouth of the Mississippi River, one of the largest rivers on the entire planet, except this version is entirely invisible, moving through the atmosphere rather than a riverbed, right up until it slams directly into California's coastal mountains. At that point, the moisture has nowhere left to go but down. When that plume of concentrated water vapor hits the Sierra Nevada or the coastal ranges and gets forced upward, it cools rapidly, and everything that was suspended in that atmospheric corridor condenses and falls as rain at lower elevations, as heavy snow higher up, in sustained, enormous quantities. Meteorologists actually grade these events on a numbered intensity scale, conceptually similar to hurricane categories, ranging from a weak AR1 up through an extreme AR5, based on both the intensity of the moisture transport involved and how long the event lingers over a given location before moving on. Here's what made the January 2023 sequence specifically so exceptional, and why the 20 trillion gallon figure became the number everyone still remembers from it years later. It wasn't a single atmospheric river, it was 9 of them, arriving back to back over less than a month, each one adding to ground that hadn't had time to dry out or drain from the one before it. California's governor described that pattern at the time as stacking the likes of which the state hadn't experienced in living memory, a comment he made in the middle of what turned out to be an 8th storm in that sequence, with a 9th already on the way behind it. That stacking effect is genuinely the core of this entire story. Any single atmospheric river, even a strong one, might drop a few inches of rain over a couple of days on its own. 9 of them arriving consecutively, with essentially no recovery window between events, is what turns an otherwise normal wet season pattern into a historic, statewide 20 trillion gallon event. It's worth being honest about what that much water actually did to the state, because the raw figure however staggering, doesn't tell the complete story by itself. That January 2023 sequence killed at least 18 people, according to California's own Office of Emergency Services at the time. It caused sections of roads to partially collapse. It flooded entire neighborhoods and forced thousands of residents to evacuate on short notice. And here's the part of this story that deserves real emphasis, because it's the piece that tends to get lost whenever a headline chases the scariest possible framing of a large number. Those same storms that killed people and destroyed property also, within a matter of weeks, pulled California almost entirely out of a drought emergency that had gripped the state for years beforehand. Before that storm sequence hit, roughly 43% of California was classified under extreme or exceptional drought conditions. Within about 3 months, the U.S. Drought Monitor showed the state with essentially no areas remaining in either of those two most severe categories at all. The state's two largest reservoirs saw their combined storage increase dramatically, and millions of Californians ended up receiving considerably more water in their allocations than they'd been granted just a month earlier. That's the genuinely strange, two-sided nature of an atmospheric river siege of this scale. The exact same event can simultaneously be the most dangerous weather disaster a region has experienced in years, and the thing that ends a multi-year drought crisis almost overnight. Now, here's why this specific history is worth revisiting right now, in the middle of August, when nothing resembling that sequence is actually happening on the current map. California's own state fire and weather agencies, through their Southern Operations Predictive Services Unit, published a formal seasonal outlook at the end of July, issued specifically to cover August through November of 2026. That outlook explicitly states that as the state transitions out of its dry season, conditions are expected to run warm, and that atmospheric rivers are considered likely as the wet season gets underway. It further notes that strong El Niño conditions currently in place are expected to bring near to above normal precipitation to the region come October and November, with the first storm system originating from the Gulf of Alaska likely arriving sometime in the mid to late October window. That is not a dramatic prediction pulled from thin air. It's the kind of routine, technical seasonal assessment that fire and water agencies produce every single year specifically to guide resource allocation and staffing decisions. What makes this particular version worth actually reading closely is that it directly and explicitly calls out the same atmospheric phenomenon responsible for that 20 trillion gallon event back in January of 2023, using nearly identical language. Let's talk about why forecasters are already thinking this far in advance, because the reasoning connects directly back to the underlying mechanism already explained. Atmospheric rivers form when there's a strong, persistent plume of tropical or subtropical moisture linking up with a storm track that channels it toward the California coastline. The strength and frequency of that setup from one year to the next depends heavily on the broader state of the Pacific Ocean, including exactly the kind of El Niño pattern currently in place this year, one that's been shaping weather systems across multiple other regions of the country simultaneously. Forecasters monitoring sea surface temperature anomalies and the broader Pacific atmospheric pattern right now are doing precisely what allowed meteorologists to see the January 2023 sequence coming. With genuine lead time back in December of 2022, they're reading the large-scale ocean and atmospheric setup for the specific signals that tend to precede an active or even historically extreme atmospheric river season taking shape. It's important to be careful here in exactly the way any responsible breakdown of this kind of forecast should be careful, because there's a meaningful and consequential difference between atmospheric rivers are likely this coming wet season, which is what the current official outlook actually states, and a 20 trillion gallon mega event is confirmed to be arriving, which it explicitly does not say anywhere in that assessment. Every California wet season includes atmospheric rivers to some degree. They're not an anomaly or a rare event. They're the primary mechanism through which the state receives the majority of its annual precipitation in an entirely ordinary year. What varies enormously from one year to the next is how many arrive, how intense each individual system turns out to be, and critically, whether they stack back to back the way they did in January 2023, without enough recovery time between events for saturated ground to drain and for reservoirs to safely absorb the next incoming pulse of water. That specific stacking behavior is genuinely difficult to forecast with high confidence more than a few weeks out, even in years when the broader seasonal outlook correctly identifies that overall conditions favor an active atmospheric river pattern for the season as a whole. Here's the part of this story that deserves the most practical attention, because it connects everything explained so far directly back to what actually matters for people living in California. Right now, in August, with the wet season still genuinely months away, a 20 trillion gallon event isn't purely a weather story, it's a water management story, an infrastructure story, and in the years since 2023, it has become a genuine, ongoing planning priority for the entire state. California has invested real, sustained effort since that historic storm sequence toward capturing a larger share of that kind of floodwater, rather than simply allowing the majority of it to run off directly to the ocean unused. That's because the same state that watched 18 people die in flooding during January of 2023 also watched a years-long drought emergency essentially end within that same 3-month window. The lesson state water managers took away from that whiplash is that both outcomes, catastrophic flooding on one hand and genuine drought-ending relief on the other, are frequently riding on the exact same storms. The difference between disaster and relief very often comes down to timing, how saturated the ground already is when a given system arrives, and how much of that water the state's reservoirs and groundwater basins are actually equipped to capture and hold, rather than let flood downstream unused and unmanaged. So where does that actually leave things, evaluated honestly, as of today? California is currently in its dry season, the same dry season its own fire outlook describes as carrying near normal wildfire potential through the fall, with temperatures likely running above normal and precipitation likely running below normal through September before conditions begin shifting in October. There is no atmospheric river event currently underway anywhere on the map. Nothing resembling the 20 trillion gallon siege from January 2023 is happening today, or is confirmed to be coming this specific season. What is genuinely true, and what the state's own forecasters are already on record stating in a formal published outlook, is that as this current dry season transitions into the wet season over the coming months, atmospheric rivers are considered a likely feature of that transition, shaped in meaningful part by the same broader Pacific Ocean patterns that have already been driving weather stories across multiple regions of the country this year. Whether this coming season ultimately produces a routine, entirely manageable series of storms, or another historic stacking event comparable to January 2023, is something that will only become genuinely forecastable with real confidence as the season itself actually approaches, typically within a lead time of 1 to 2 weeks, once a specific atmospheric river system is actually forming and can be tracked directly. Let's bring this back to something genuinely practical, because that's the actual point of walking through a story like this in this much detail, rather than simply repeating a large, scary number without context. If you live in California right now, while the state is still firmly in its dry season and before any specific storm system is anywhere near the map, is a genuinely useful moment to actually think through your household's flood and storm preparedness, rather than waiting until an active atmospheric river warning is already in effect. That means knowing concretely whether your home sits in a flood-prone area according to current mapping. It means understanding your specific property's landslide risk if you're located anywhere near hillsides, scarred by recent wildfire seasons, since burned slopes lose the vegetation that would normally hold soil in place during heavy, sustained rainfall. And it means simply being aware, going into this fall and winter, that California's wet season, whenever it arrives in earnest, has a well-documented, repeated history of swinging rapidly from drought relief to genuine emergency within the exact same sequence of storms. None of that requires believing that a specific mega event has already been confirmed for this coming winter. It simply requires taking the state's own current seasonal outlook seriously, in the same way coastal residents along the Gulf Coast take a hurricane season outlook seriously well before any specific storm has actually formed on satellite imagery. The number that anchors this entire story, 20 trillion gallons, remains one of the more genuinely fascinating examples of how the exact same weather event can tell two completely different stories depending entirely on where someone was standing when it happened. For the 18 families who lost someone in those January 2023 floods, and for the thousands of residents who watched roads collapse and neighborhoods fill with water, that number represents disaster, full stop. For the millions of Californians who spent years living under mandatory drought restrictions and watched reservoirs return to healthy levels within a single 3-month window afterward, that same number represents relief arriving all at once. Both of those things happened as a direct result of the exact same 9 storms. As California's own, predictive services teams now watch sea surface temperatures and Pacific storm track patterns build through the remainder of this month and into September. That fundamental duality, the same atmospheric mechanism capable of ending a drought and taking lives within the identical sequence of events, is precisely why a seasonal outlook that simply says atmospheric rivers will be likely carries far more weight than its plain technical language might suggest to anyone hearing it for the first time this week.